Hello, everyone. Um, yeah, so today we will talk about battles in WebVR, WebVR battle. And basically, we will talk about the state of WebVR today and solutions we can use right now in 2018 to develop VR in the web. So a little bit about myself. I am Vladimir Novick. This is my Twitter handle. I just need to figure out where are the slides. Yeah, here. So this is my Twitter handle. I'm an independent consultant, and I do lots of stuff in web, mobile, VR, AR, and IoT fields. I also published a book on last August, React Native Building Mobile Apps with JavaScript. It's available on Amazon Unpacked, so you can just check it out. So today we will talk about several things. Our agenda for today, we will start with history of virtual reality. We will understand that virtual reality is not so new as you might have thought about. We will talk about WebVR API and how we can use it. We'll talk about various solutions such as A-Frame, React 360, and various game engines. We will talk specifically about Unity. And in the end, we will see which VR solutions we should use today for our specific app. So let's talk about virtual reality and how it started. Just yell it out loud. When do you think the first attempt of virtual reality started? Just yell it out. 70s, something like that. Somebody said 70s. 18th century. 360 degrees murals, paintings, painted all over the walls. That's the first attempt of virtual reality. So virtual reality is out there for ages. Then in 19th century, we had the stereoscope by Charles Wheatstone, which you can put near your face, and you see like two separate images. And this is the basic principle of virtual reality, how it works. We have two different images with different change of perspective showing to our eyes. Then in 1929, we had the first flight simulator, huge machine that we used to put on, well, not us, but flight pilots, used to put on their heads to try to fly between pixels, something. Then in 1930s, there was the Pygmalion Spectacles, the first book that actually mentioned some kind of VR. Really nice book, by the way. In 1950s, we had Sensorama, which was a machine you just put your head in, and you see some semi-3D virtual thing. In 1960, we actually had the first HMD, head-mounted display. So it's not 70s, it's 60s, we had the first head-mounted display. Between 60s and 90s, there was a huge progress on VR side. We had HeadSight, first motion tracking device, which sounds crazy, right? We hear about motion tracking with these new devices that are available right now. It was available out there in 60s. In 65, there was the Ultimate Display by Ivan Sutherland, which is the amazing thing you should check out. In 1968, there was World of Democracy. You will see pictures in a bit. It was like head-mounted display. Because of its weight, a person cannot put it on his head, so it was like hanging from above, like a sword of Damocles from mythology. 1969, there was artificial reality term that was born, and in 87, the actual term of virtual reality, the actual name was born by Jaron Lanier. And from then on, virtual reality is called virtual reality. In 91, there were virtual reality arcade machines. Who have used them in 90s? So I see some people use, right? Okay, so in 90s we had the movie Lawnmower Man, which was based on the principle of virtual reality, and the whole plot was around virtual reality. 1993, there was mentioned Sega before that, but so Sega announced new VR glasses, though they had their headset in 1993. 1995, they had Virtual Boy. And 1999 Matrix. I mean, come on, that's what populated virtual reality the most. Like people start discussing how if we are living in the Matrix, if our actual reality is the virtual one and stuff like that. So early 2000s was relatively slow, but at 2010, Oculus prototype was created, which Oculus is one of the high-end consumer headsets. And from prototype to get to the point it's now, it had to develop some kind of additional technology. There was Valve, the creators of HTC Vive. They discovered low persistence displays. The refresh rate became better and FPS became better. Then they started in 2014, they created their own prototype of HTC Vive. Google announced Google Cardboard, Facebook purchased Oculus, so from that point it just started running. Sony purchased Project Morpheus, which is PlayStation VR. And 2016, the big boom happened. The consumer VR headsets were released. And I'm talking not about like the cardboard or mobile headsets. I'm talking about high-end headsets. I'm talking about HTC Vive, Oculus, PlayStation VR. And now this year, at the beginning of the year, Vive Focus was released, which is a headset which is not tethered to anything. It's not, you don't put a phone inside. You just get VR on the go. The same with Oculus Go. And the recent news, before the recent news, HTC Vive Pro released, they increased resolution. And the recent news, Facebook at the Fate announced their prototype called Half-Dome, which basically increased resolution field of view 140 degrees instead of 95 degrees, something like that. And this is the state where we are today at VR. So this how it looked like at the beginning of the century. This is a stereoscope. This is the first head-mounted displays. Leon spectacles. This is the Sensorama. You put the head inside, and the sort of the Oculus, the flight simulator. These are arcade machines I'm talking about. And you probably, if you've been out there in the 90s in like huge malls all around the world, there were such machines. Sega glasses look pretty good actually for the 1993 when they were released. And this was the Nintendo Virtual Boy. Right now, headsets look like this. I mean, high-end headsets. But what about web? We are here at web and mobile stage, so we want to talk about web and how like you can implement VR in the web. So on the web side, it progressed from WebGL to WebVR. It started with the first spec of WebGL, basically by running OpenGL inside your browser. It was called back then Canvas 3D, and it was conceived in 2006. Spec was released in 2011 by Apple, Google, Mozilla, and Opera, all the major browsers. 2016, WebVR 1 was announced. Last year, WebGL 2 was released, and basically that's where we stay today. So WebGL is OpenGL in the browser. WebVR is a spec letting us connect to our headsets. I mean, any headset, like high-end headsets, use controllers, use the gaze, use like tracking and everything on the web while building your websites. So the raw web VR API, you will see in a bit how it looks like, but check out the stage of web VR. I mean, you don't have to, I know it's a small picture, but you see that mostly it's red. You don't have lots of support on WebVR today, but it's getting there. At some point, like a year ago, you could have used WebVR only if you would download Firefox beta with the flags and stuff like that. Right now in Firefox, it just works. In Chrome, it's not. Like all the Chrome is red. And surprisingly, it works in Edge. So the raw web VR API is a huge spec, but the main idea is you get VR display from Navigator you have on the web. By running Navigator get VR displays, you request VR session to present VR content. You start render loop. On the web, you have request animation frame, which in request animation, you can run your render loop. And whenever user exits, you just stop your render loop. So it may sound simple. The code is huge. You need to code every little bit of it. So there's another project. Instead of just using raw web VR, you can use A-Frame, which is a really huge project. It's made by Mozilla, and they really invested in making it great. It has a huge community. So right now it will be a little bit of code dive, and then we will see demos how we can differentiate between technologies. So A-Frame is powered by 3JS. 3JS is WebGL, is a library that gives you an ability to interact with WebGL easier. With A-Frame, the code looks like this. You use A-Frame script tag, you just import A-Frame script tag on the page, and you use HTML to structure your scene. So you have a scene component inside body, have a box, a sphere, a cylinder, and basically after defining a scene, you use entities. Any entities can be simple ones, box, cylinder, circle, stuff like that, or they can be complex ones, and you can actually import models there. You can use it with shaders, you can use particles, you can use whatever you want. And A-Frame uses, you use coordinate system to position entities. Instead of just having like 2 dimensions, you have 3 dimensions, meaning you have 3 axes, right? So we will talk in a bit about coordinate systems and how it looks like. When we develop with A-Frame, we have entity component system that works with A-Frame. We will talk about component system in a bit. Coordinate system, well, basically there are 2 different coordinate systems in OpenGL. There is a left-handed or right-handed. And why it's called so. In A-Frame, we use right-handed, meaning if you take your hand, point it like this. This will be the z-axis, this will be the y-axis, and this will be the x-axis, meaning positive x will go that way, positive y will go that way, negative z will go that way, meaning if we want to position something in front of us, we will give it negative z position. So this is, in a nutshell, how the coordinate, like positioning works. But there is also rotation. So rotation, we use the thumb rule, meaning we still use right hand. If we point at our thumb along the axis, the positive rotation will be along our fingers. So if we point at y, rotation over y will be like that, rotation over x will be like that, and rotation over z will be like that. So as you can see, you can use rotation in degrees in the following way. So yeah, you use the thumb rule. But when you use rotation and then we rotate something and then we position something or scale something across axes, axes change also with rotation. Meaning if we have something in the zeros coordinate space and we rotate it, like let's say 90 degrees, our axis also rotates. So we need to keep that in mind and while working with the rotation and stuff like that. So I said previously with A-frame we use entity component system. And component system is basically no inheritance. We use composition, like things from functional programming, right? So we use composition of inheritance, which eliminates problems of long inheritance chain. We promote clean design. It's scalable and it's extensible. We can argue on that, but it's a proven fact in game development, component-based systems like entity component systems that are used, for example, in Unity game engine or Unreal game engine, are more dominant in game development space. In A-frame, it looks like this. We have entities, as I told you previously. But entity is just a simple tag. It doesn't have anything inside. It's just like putting a div without anything. So components are what makes the actual model. So on our entity, for example, we have particle system, which in this example is custom-made component with several presets, with colors, with particle count. If we want entity of a sphere, we can use, instead of a sphere, we can use a entity and pass geometry as a primitive sphere. And it goes on. We can create our own components. We can just attach them to entities. And we can compose them in groups and call it systems. You can treat them as components, are basically HTML attributes that has lifecycle methods and focus on data, while systems more focus on logic. But it's totally up to you to separate this if you want so. So define components as simple as that. You just register component, hello world, schema, various lifecycle methods, and basically that's it. Provide lifecycle hooks, hook it embeds, and you're done. So there are various community packages. You want to use physics, right? You write WebVR, so obviously you will have collisions. You will have some, I don't know, throwing balls around, throwing like particles, shooting at people or whatever. So you will need physics, right? You will need various extras like animation, different models, extensions, etc. For example, you want to use leap motion. Leap motion is like a tiny controller that can track your hands, so there is an extra for that also. And there are a bunch of others, you can Google them. A-frame also comes with inspector, pretty nice one. I told you about the positioning, and you may think, okay, it sounds complicated, right? I need to remember how the axis works, stuff like that. So the debugging tool looks like this. You have inspector, you can rotate things, look like 3D modeling program. It has a scene graph, it has a viewport, and it has components panel on the right. So that was one solution out of 3. The second solution is React 360, which was previously called React VR. And people might think React VR or React 360 and A-frame are kind of competitors, but they are not really, and we will see in the end why they're not. So React 360 is based on React Native idea. When we have React 360 application, we have runtime, which is a bridge between our React application and WebVR content. And we're running from here to here. Runtime looks like this. We have, in runtime, it's a file called client.js. We can define executors. We can use WebSockets as an executor to our bridge. We can use various, like iframe executor if you don't have WebSockets, WebWorkers, stuff like that. You can define main background. You can set 360 video. You can define your own native models. Just write a bunch of your own models that interact with 3JS or whatever you want. You can render to custom surfaces, meaning you want to render to like create 3D mesh and render on top of it. You can do that. You define here custom locations where you can put your models. React app looks relatively the same as it looks for React Native. We have views which are containers of our UI elements, and we have VR buttons and text and stuff like that. And the great thing about it, we have state management system built in inside React, and we also can use it with the React state management system, such as Mobic, such as Redux, Mobic State Tree, you name it. So it resembles React Native. You have React lifecycle and state management. You style with yoga, meaning you have Flexbox inside VR, which is amazing, right? You can lay out elements inside VR on your UI screen. You can mount 3D objects, as I said. You have audio. You have special audio, meaning if you are close to the object, you will hear from the right headphone. If you close on the left, you will hear from the left headphone. We can handle input with cursors or with our VR controllers. So in both A-Frame and both React 360, we need to acquire assets, right? We need to bring those 3D models and texture and stuff like that. So I kind of compose several resources for you. You can check them out. You have Unity 3D Asset Store, which is amazingly great, and I will show you in a bit how it looks like. We have TurboSquid, where you can buy models, Sketchfab, the same, mix some more models with animations. You can model yourself in Blender if you know how to do that. You can use various high-end textures to make your simple model to look really great. And you can use Substance Source, which is a separate product with really premium textures, meaning like live scans of actual surfaces, and it looks pretty amazing. So the third option is Unity. This is the logo of Unity. So this is the difference. Check this out. The rendering looks like totally superior, right? And this is the actual scene from Unity demo. And it's one of the top of game engines available. It has superior rendering, ECS architecture, use C# for programming. It has visual editor and inspector. It's extensible with like tons of add-ons that you can purchase or you can just download free. And it can compile to WebVR until, like, I think last year, at the beginning of last year, it started to like be available. Like compiling to VR was a beta, and then right now it's just the standard solution. So, conclusion: you may think that I showed you Unity, and it's looked totally great, right? So you may think, okay, I will develop everything in Unity, and I'll just get the premium quality, right? But we have a battle, right? So who wins in the battle? It depends on your use case. So raw WebVR, it's not that easy to create. If you need like your really custom code of your own without like any dependencies of any libraries, you can do that. Not advised, but I mean, I'm not here to tell you what to do, right? You can use A-Frame. It's good when your VR app is dealing with complex 3D models, shaders, particles, physics, etc. It's not really good if you're dealing with UIs-oriented apps, which when comes React 360, it's really good when your application is in VR space. Like, let's say you have a virtual tour, right? So have VR space and you have a bunch of menus that you can click and just change direction, stuff like that. That will be perfect use case. And if you're planning to do a game, you just use Unity. So the main idea of this talk was to show you the solutions and how it works, and the idea that you will start building VR today. And I prepared several demos for you here, so I have, I think, a minute, so I will show them. Let's see. So this is how React VR looks like. Have a simple UI here, which will be kind of painful to create in Unity, by the way, from the scratch. I have just regular counter over here. So for this use case, just having a 360 image and this kind of stuff, I can use React VR. For A-frame, I'm running against time. This is A-frame, for example. You have more complex stuff. You have particles of rain. I don't know if, yeah, you see it. You have ocean, which is, by the way, community package. You have a bunch of animations going on here and stuff like that. And let me just stop it. Unity, okay, it's not open the editor, but doesn't matter. I have the backup. Where is it? Yeah, Unity is good for games. So I have a game here, which will hopefully load. So I have a game. It's not VR, but it's just like a simple game. You see, like the complexity is much, much bigger, right? So these are basically all our three solutions that. Yeah, I forgot. Where is the last slide? Sorry about that. I just need to open the last slide of saying thank you for attending this talk and start building WebVR today. And I hope you enjoyed it.